I'm Justin Murray from Technical Marketing. Some of you folks have seen me in action before, so regard this as an update to what I delivered back in February. This is the real product this time. When I was showing you back in February was a preview, technical preview. They're very similar, actually. In fact, the only things that have changed on the architecture since then are the names of some of the NVIDIA things. Like at that time, we talked about Triton Inference Server. Now we talk about NIM, NVIDIA Inference Microservice, on the top layer. We didn't mention Retriever before. That's the microservice that retrieves data from a vector database in the RAG design. That's changed. But apart from that, the only other changes are the number of hardware OEM vendors at the bottom here. And so what I'm going to do in this 25-minute section or so is walk across the blue layer, which is the VMware Private AI Foundation with NVIDIA layer. That is an add-on, as you rightly said, to VMware Cloud Foundation, and tell you what each of these pieces do, and even demo some of them if we have time. So that's the agenda here. Now, RAG has been thrown around a little bit. I thought I was going to introduce RAG in my section, but obviously you folks know it before. For those of you who are unfamiliar with RAG, it's the idea of complementing or augmenting the large language model with private data that's kept in a separate database. A particular kind of database, a vector database. And we provision this vector database for you, and we provision the chosen large language model that was chosen by the data scientist. We provision that into the NIM container for you. You'll see that automation working in a second. The benefits of this are large language models sometimes hallucinate. Large language models do not cite their references when they give you an answer. They don't say where that information came from. And large language models can therefore be a little buggy at times. And what we're suggesting here with RAG, as our take on RAG, is to take private company data and load it in via an embeddings model, load it into that vector database, and that becomes the source of truth for private data. Like, what are the features of the upcoming version of VCF? Private to VMware. Somebody inside VMware is answering a customer question. They want a quick summary of what features are coming. That sort of summarization, we've already got an application deployed on an LLM to do that internally. And actually, we put it out as an open source example application.
Are you hosting the embeddings model on this infrastructure too?
Yes, we are. That's being held in a separate microservice / container called a Retriever embedding model. That's a smaller model. And the question about training, you will fine-tune these models. You won't leave them pristine. So there will be a small amount of training done by data science on the embedding model in particular, perhaps on the large language model, the composition model, the model that makes up the English at the end. There'll be a certain amount of training done there. Fine-tuning is how I'd call it. So it's not exclusively inference, although inference is the main theme. So Jake already spent some time on that, but the reasoning I'm going to give for why VMware Cloud Foundation is applicable is by looking at a day in the life of a data scientist. Now, as we've portrayed it already, they're choosing models. They're testing models. They're going to Mistral or Hugging Face or Meta or NGC, NVIDIA GPU Cloud, and downloading models. Now, I'm portraying this as a free-for-all. I'm going to put some ML ops governance on this towards the end of my talk, on this activity of downloading models and testing them. That's what the deep learning VM is for, is bringing down models and testing them out in a safe environment. And then they're doing infrastructure setup, as you heard from Jake. A lot of their time is in, do I have enough GPU to do this? I struggle myself between my single A100, two A100s, and I'm very jealous of my colleagues who have H100s at the back of the room here. I'm constantly looking for the right infrastructure to suit my model, because NVIDIA is now in the business of fine-tuning models for particular GPU types. And this is happening not just on one person's, but on many people's desktops or many data science teams operating together. And they're all doing slightly different things. They're using different toolkits, different platforms, PyTorch, TensorFlow, all of this, and all of this is changing all the time. There's a new model per week. There's a new toolkit per month. How do we keep up with this pace of change? Well, the data scientist is asking the IT people, I need to change from 1 GPU to 2 GPUs on my environment tomorrow. And then I need to change back again on Friday. That pace of change is only really acceptable in a virtualized environment. And VCF, we believe, is the answer to that. The second problem is data scientists up to now has been spending the bulk of their time over here dealing with serving infrastructure, dealing with process automation, trying to use shell scripts to build this quickly for themselves, and then monitoring the system to see, is the GPU actually being used in the way I thought it was? That's not their business. That's the business of IT. And so VCF is focused on managing that left-hand side and really leaving the data science team to do real data science on the right-hand side. The idea is to present these people with a cloud-like interface to the infrastructure that they need, plus the tooling, and that tooling is largely in the NVIDIA microservices, the NIM, the retriever, the operators. And we'll do that in the context of just the simplest thing in the world, a deep learning VM. And we'll also do it in the context of a Kubernetes cluster, which is where you graduate to when your application's ready and your model is ready to go. So we'll show those two things.
Question on the infrastructure work. Are you referring primarily to work on-prem, or are you referring to what they're doing in cloud providers that they can more easily do on-prem?
The first of those two, on-prem.
Okay,
yeah.
on-prem.
The main thrust of this is on-prem. Okay. It's not exclusive. It will run on clouds as well, but this is an on-prem story to begin with.
Okay. Thank you.
So you asked about vSAN being required. vSAN is required for the management domain, which is the master domain from which everything else is controlled in VMware Cloud Foundation VCF. So we do a separation of concerns here between management concerns and workload concerns. And these domains are big things. They could be for the entire data science department. You could be a business that has many subsidiaries. Each subsidiary might have its own workload domain. The idea is isolation. We keep these separate. Each of these workload domains has its own vCenter, for example, to look after it. But we add a bunch of tools like automation tools, which you're going to see, operation management tools, and data services to generate that vector database. We add those into the management domain. They have their effect in the workload domain. The actual thing they're provisioning is in the workload domain. So the things that are provisioned are these simple things called AI workstations. Translate that to a single VM, a deep learning VM. I keep referring to deep learning VM. I'm going to tell you what that is in a second. That's the place where things are tested. When things get a bit more serious and need scaling, we generate a Kubernetes cluster on the fly for you so that you can quickly get to work on that. So all of those things belong in workload domains. In our POCs with customers, in our future work with customers, we will ask them to dedicate a workload domain to the data science work to begin with. That's a very, very quick overview of VMware Cloud Foundation. Under the covers, it's got NSX, it's got SDDC Manager to create these workload domains. It's got a whole bunch of tools, 3 of which we're going to look at in a little more detail. So on top of that infrastructure is what I'm going to call a supervisor cluster. It's a Kubernetes cluster whose job is supervising others. Its job is creation of these things like workload clusters. A Kubernetes cluster is made up of nodes, which in our world are VMs, and it's made up of namespaces and pods, which every Kubernetes person deals with these. They do a kubectl get pods, kubectl get namespaces. So we implement all of that within VMs. The VMs are direct parallels to the Kubernetes node concept. A node is a VM. And that whole thing is generated using one command to the supervisor. And that command is itself a Kubernetes command. kubectl apply my YAML generates me this thing in one command. Now, this is all done using APIs as well, of course. It's not
So in this case, you don't need the container operations advanced services. This is all basic vSphere, basic VCF.
This is built into vSphere. You turn this on at vSphere installation time, at vCenter installation time. This is Kubernetes for free with vSphere.
Okay. Yeah.
Yeah, and the ability to create separate clusters for separate data science teams at will. That's what's going on here. On the right-hand side, you see a completely separate service, which also is usable via the supervisor, and that service is the creation of databases at will. MySQL, Postgres with PG Vector, the vectorization of the relational database, are all configurable to that data services appliance, if you like.
And there's a VCF advanced service called Data Services as well, which is not that.
This is Data Services Manager. I think we're talking about the same thing. This is a feature that's built into VCF itself.
I believe there's an advanced service version of that, but it may be separately chargeable. You're talking about the free.
There may be. I'm not familiar with that. This is part of VCF. When you buy VCF, you get this. There may be an advanced flavor of it, but I haven't come across that.
This is where, and I know VCF is, it's the maximum lovable thing. And so within the maximum lovable thing, there might be elements of what was previously called Tanzu, elements of something or other, or even going back to the SQLfire, Gemfire days of, what's been done to make Postgres more accessible, usable, scalable, etc.
Yeah.
Is there a simple explainer that you've seen or come across that says, here are the ingredients lists of everything that's included and what maybe its origin story was? Because I think when I think of a VCF customer, if I think of a current Tanzu customer, they may have actually had the relationship going back to pivotal days. Yeah. They may have had those original stories. So understanding kind of like what we had some earlier questions around investment protection, understand where you are.
Yep.
We did get a very clear answer on if you're transacting now going forward, as long as your VCF 511, I believe, was
that's right.
You're good.
Yep.
But obviously there's lineage or a timeline of accepting, embracing and doing everything from the planning, the integration, the monitoring, the optimization to get it in place. How are you guiding to even throwing data services VMs up there as a concept? I can see the little logos, but
yeah.
How does that fit into a longer life cycle that maybe is not greenfield? It's a lot of brown, a lot of things that have happened before. How are you navigating that?
We're really doing that in document form. So
Okay.
there is a deep level validated solution for this that is multiple pages that we put out there to customers to say, here's everything you need to do private AI.
Got it.
It includes data services. It includes vector databases. It's deeply technical, and I'll refer to it at the tail end. We have some previous documents that refer to how life was before that.
Right.
That we can also supply to a customer. But really, we're focused on what VCF has to offer.
A product experience from beginning to end.
Absolutely.
Okay. All right.
Absolutely, yeah. So there will be 4 or 5 references towards the end here.
That's the bit that I really need to see, is what the experience is like for me as an application developer who is used to doing CI/CD things with Kubernetes. Like I can spin this up in Minikube on my laptop.
Yep.
And if I am doing this in a silo over here, this feels very similar to the cloud challenge of app devs got used to driving things in AWS and didn't want to deal with central IT because the experience was horrendous.
Yep.
What is the experience going to be like for those people using it?
It's coming up. Give me 2 more minutes just to get through. It's coming. So my first experience was I took a manual approach to deploying a VM, and I did all the tooling, all the setup, all the networking, storage by hand, believe it or not. And that was about 9 months ago, and I'm never going to do it again.
Your own personal time and motion study.
Yes.
Yeah.
So now, if you ask me to do it, I would create an AI workstation, which is a precast image that somebody downloads from VMware.
Yeah.
It's got the appropriate setup for vGPU settings. Virtualizing a GPU means I can vMotion that. It's got the appropriate advanced settings inside the VM already, and it's actually got Conda and PyTorch inside that deep learning VM for me. So the idea is this thing would be used for development, for testing that model, for its accuracy, its lack of bias, its security, etc. And then it would get promoted into a cluster for serious application use.
What kind of time savings? You laid it out. Like, so I had a Gantt chart. How much shorter is the chevron with this as opposed to what you did before when you did it the old-fashioned way?
This is probably 5 to 10 minutes. This is at least a day.
Okay.
At least. Yeah. Starting from scratch.
Starting from scratch.
Kubernetes cluster, probably 15 minutes, easily 2 or 3 days, maybe longer if you're inexperienced at Kubernetes. So there's a considerable time saving here. So
And in this case,
and the level of automation, sorry, I'll come to you. The level of automation gets more intense as you go up this chart. So there are 45 steps that I'm going to show you, not one by one, to create a Kubernetes cluster. There are about 15 to create a deep learning VM. You would do those all by hand without this technology I'm going to put in front of you.
so the AI workstation would be sharing a GPU, virtualized GPU kind of solution across multiple workstations. Is that how it's would play out?
Potentially, if your model will fit into a portion of a GPU, yes, you could create these virtual GPUs, and we'll see the choices that we get here, such that you and I are sharing a physical GPU, even though we don't know each other.
Right.
Yes. So this is the part of the developer experience here. This is what we want to put in front of a data scientist to say, which one of these two things do you request? No tickets, no talking to IT. A lot of IT work has gone on behind the scenes here, but this is what the data scientist or the platform engineer serving the data scientist would click on. And we'll do this in demo form in a second. We started out with just 2 options. As we released the product, we put even more options in there. Do you want a Kubernetes with RAG in it? Do you want a Kubernetes with RAG plus chatbots in it? Do you want an AI workstation that just has the PyTorch in it? A whole bunch of different options for the data scientist to choose from. And you're going to see those choices here in a second. I keep mentioning this deep learning VM. We shipped this image out from packages.vmware.com with the Ubuntu operating system 2204, appropriate settings for virtual GPUs for sharing, a Docker runtime, and Conda and PyTorch. That's in the base image.
Okay.
The rest of the data science tooling is in the NVIDIA containers that we're going to download at first boot time and load into this VM. So we're going to talk to NGC or talk to a private repository and get the NIM container and the retriever container from there and download them and place them into the VM and fire it up.
Does the AI platform include BitFusion or whatever it's called now?
No, BitFusion is no longer supported by VMware.
Okay.
This is purely, in this world, the consumer of the GPU and the GPU itself are on the same server.
Okay, got it. Thanks.
Okay, so this is what a deep learning VM looks like. I'm showing you this because IT admins will love this screen. They use the screen all day long. It's just a regular, AI workstation is just a regular VM, 128 gigs of memory, configurable, 16 virtual CPUs, configurable, and as many GPUs as you ask for and is available to you. There are 2 GPUs attached to this VM here. There could be 4 or there could be 8 if we were really doing something big here. So that was derived from an image that I loaded into the VCF content library, which is where images for everything live. Images for Ubuntu, images for VMs. It's just another image. People who manage VMware are very familiar with this. This is the thing I cloned by hand and took me at least a day to configure it with everything that was automated for me later. So let's see that in action. Let me jump out of slides here for a second and go to another screen. And let's deploy an AI workstation. So here are the 2 choices that I just showed you. I'm going to request an AI workstation. I'm a data scientist here. You'll notice I need to make 2 decisions. Well, a small decision like what do I name this thing? But the big decision is what power in GPU terms am I allowed to use? This has been constrained by IT. And I constrained it severely here because I'm the end user to just 1 GPU or 2 GPUs. Those are your choices.
So a question on that. What if I don't like the constraints that IT has decided to give me?
That's a good question. You'll have to speak to them to open those up. But I'm portraying a pretty extreme situation here where I've constrained it down to a small number of choices. I fully expect that this would have 10 different entries in the same way that when you go to AWS, you have 10, 15 different EC2 instance types.
Not which are probably ignored, but yeah.
The idea is to replicate that experience here. To simply say, your instance, how many GPUs does it have? And I'm not going to open up the world to you, but I'll be kind.
Do you share any cost implications at this point when they're selecting those parameters? Is that something
that will come a little later when we know how much is being used, in fact. Yes,
okay,
that's coming.
All right.
So give me a password for this new deep learning VM. Firstly, tell me how many GPUs you want. Give me a password. And one last thing, tell me which of a series of packages of containers from NGC or from your private Harbor repository you're going to be loading into this deep learning VM. So this set of things is also configurable in the automation tool. So this is not going to stay static by any means. We started off with a few things like TensorFlow and RAG, an example RAG application. So this is the one I'm going to choose. But it's not confined to this. You can edit this if you have appropriate access rights in the automation tool and make this wider. There's one thing we need here, which is we need to have a key, an NGC key. And now automation is doing what took me a full day to do in the space of, I've speeded this up slightly, in the space of about 5 minutes.
And just to reiterate, which persona are you right now in this demo? Are you
I'm a data scientist, or I'm a DevOps person, or platform engineer, or IT admin person who's serving that data science.
I got it.
All of this is doable through APIs. If you wanted to script this, you could do this in a non-GUI fashion, which might be the case if you have a very large community.
Do you have any customers that are presenting this who say, like Backstage, for example? Showing them a service catalog,
Yes.
tiles upon which to click. And
Yes. Let's see here. So we've got our deep learning VM. If we click on it, we can see the artifacts that were created behind the scenes. This is of somewhat engineering interest. We're using a particular API here called the Cloud Consumption Interface, which is the API to that Supervisor cluster that I mentioned to you earlier. So this is done, I think. So what we're going to deliver to the end user is a URL to take them into their Jupyter notebook or whatever environment they want to be in. We want it to be in a sample application here. Because a large number of our audience is IT, we show them the IT screen to say this is what the VM ended up as. And if we click on it, we can see that it does indeed have the GPUs that we asked for. So IT can confirm that they got no more than they wanted, and they got exactly what they wanted. We'll cancel that and go back. And now, getting closer to the developer now, we're going to look at what services, what microservices exist inside that VM that I can use. So to do that, I'm going to go to the command line. Some apologies about command line here, but it's a technical presentation when you're on the command line. And what we see is, how was the driver done exactly? NVIDIA SMI, some of you may know, is the command that tells us whether the driver is there or not. If it's not there, we're currently inside a VM. We need to check with our host as to what the master driver is. So that check is done for you. And I can guarantee you, I've spent whole weeks of my life on this subject. I'm not going to do it again. This automation is doing it for me. It's checking the host to make sure the host is at the right level. And it's installing the appropriate NVIDIA driver into my VM right here at first boot time, so that I don't have to worry about that anymore. Not only that, but it's also installing the containers that are suitable for this model. What's going on here is we're logging into nvcr.io, which is NVIDIA Container Repository.io, NGC, and we're downloading the RAG package that is at the latest version, the RAG example application, and downloading the appropriate containers to drive it, the appropriate microservices, which will be the NIM and the retriever. And I'll explain what they're doing in a little while here. If we were to do a Docker PS, this is all running against Docker, very familiar to everybody, inside the VM. I would see 5 containers in there. 2 of them are the NIM and the retriever container that were downloaded from the NGC and started up in this VM. This same principle applies to Kubernetes. It's just a little less visible to you in the Kubernetes world. So these are NVIDIA artifacts that have been downloaded in the DLVM boot up time. I could take a subsequent step and put them into my private repository now so that I have more control over them next time. And they're active now and running. I can go inside the NVIDIA inference service and see exactly which model has been started. This one is Llama 2, 7 billion. It's a small model. And exactly what the parameters are. And if you're very sharp-eyed as a developer, you'll see port number 999 here is the OpenAI API port. In other words, if you have built an application on OpenAI using their APIs, if you're a developer that has done that, and many developers have, then that same application, by changing the URL that it talks to, can now talk to this on-premises model. And vice versa. We can take, because OpenAI is becoming the API of choice for building these things, we can use the same NIM on-premises or in the cloud or against OpenAI's API.
Justin, I'm getting kind of concerned in here that there's a lot of automated deployment of images that have specific versions of components in them. And as an enterprise environment, I would need to be able to control that.
Yes.
You did mention using my own Harbor registry to hold, or whatever container registry to hold these container images.
Correct.
But also there's this appliance that's come down. What's the lifecycle control ability to not use the native appliance and to have my own gold appliance?
Yes. In general, we're dependent on a private repository to control the current authorized version of everything. So the authorized version of these containers that I've just downloaded, the authorized version of the model, we're going to put all that later on in my talk. We're going to put all that into a repository.
If I've got a Git repository somewhere that's versioning all of the supported allowed versions, all of the libraries that can be in those container images,
Right.
but also everything that's in that Ubuntu image as well, and bring that out of one place?
Yes, we can get that for you. We focused initially...
And control it from one place.
Yeah.
I don't just want to hear what you've got, I want to make sure that I've got what I need.
The reason I'm hesitating is the case is slightly different in the case of the DLVM to the Kubernetes world. In the Kubernetes world, we'll present you with the catalog of authorized versions of Ubuntu that are applicable to you. We can do the same in the DLVM world, but we focused principally on model versioning and container versioning to start with.
Yeah, application focused rather than infrastructure focused.
That's a great question. That's something we do need to pay attention to. Just for your information, the model number is here. You can change this, of course, in the automation tool to the most appropriate model for you.
I'm going to want to pin versions all over the place.
Yes, that is a real problem.
The biggest challenge I've had doing this sort of stuff by myself is that when I update, let's say Docker or something like that, NVIDIA doesn't work, or the CUDA down level or up level has to be done.
Right.
It's a morass to try to keep all this stuff working.
Well, this way, you'll know that NVIDIA has tested the configuration that we put together, and VMware has further tested it. So that we've established that all of the versions are interoperating together. We're trying to protect you against that problem, exactly. And we've heard that multiple times. I updated Python, nothing works anymore. This is a way of stabilizing that environment, at least for some period of time. So I'm not going to go into the application. We're going to see the application in a little while. I'm going to go back into slides for a few seconds here, and then come back to this demo. But just to show you that Kubernetes is another step up from this. So in Kubernetes, as I explained, you have pods and namespaces. What we're doing is provisioning everything into the appropriate pods. So these are the containers and other things on the right-hand side that are either in your local repository and carefully controlled, or you're willing to take the latest from the NGC if you're doing advanced work, you're doing research work. And so what we're doing is placing those into pods for you. You no longer have to construct your own Kubernetes cluster. It's done for you, and it's started up. I mentioned a vector database as a model or a place where private data is held. We will provision Postgres or other databases, and we will put the PG vector layer on top of Postgres. Postgres is, of course, a relational database. PG vector allows embeddings and vectors to be stored and retrieved in that vector database. We like Postgres because some of the developers of Postgres used to work for us. The original developers from Berkeley worked for us. But also, it's been around for a long time. It's got RBAC, role-based access control. It's got encryption. It's got suitable security mechanisms on which we can layer other things like NSX to protect that private data. This is where the company's private data would be held. It's okay. So let's now do a demo of Kubernetes very quickly, and this will be just a short introduction here, and then we'll get into GPU monitoring. So let's look at an application first. Now, this is not the most exciting application in the world. This is a chatbot application, which I'm just going to use to illustrate a point here. So we ask a question of our chatbot, and the question has to do with some proprietary software, and the chatbot doesn't have the answer. The model doesn't have the answer. That question went directly to the large language model. What we need to do to solve this problem is put some information into the vector database, which I'm hiding the mechanism from you because it involves using the retriever and other things. But simply say that when I drag a file into this box here, it will go through the retriever model and get loaded into the vector database. That's happened behind the scenes. Could be happening once a day, once an hour, once a minute to keep data up to date. So we've done that. We've loaded our data in. We go back now and ask exactly the same question, but this time with the vector database active and submit the question. Knowledge base there means consult the vector database before you answer my question, please. We go to the vector database, find out if there's any data in there. There is because we placed it there, and now we have a far better answer. So we've used the large language model's capability for summarization, but really the large language model still knows nothing about our private enterprise data. We could, offline from this, go through a fine-tuning where we supply that data into the model, but really the vector database is the main source of truth here. So I was on the path to configuring a Kubernetes cluster. Let me show you how that was deployed. So I request a Kubernetes cluster this time, and it's the same pattern, except that Kubernetes clusters have different VMs for their control plane than they have for their worker nodes. So the worker nodes are the places where the GPUs are operating. This is a virtual GPU, so it could be just a share in a physical GPU. And if it were a share in a physical GPU, I could vMotion this live migrate it from one host to another. In this case, I also need the key, and here I've customized my automation to get a Hugging Face model, not just a regular model. So I go off and submit this request and walk away for 15, 20 minutes, and at the end of that time, I will have a Kubernetes cluster fully loaded with that chatbot application and all of the containers needed to support it. So, as I mentioned,
And that would be something that could potentially scale up or down, auto scaling to thousands of users potentially, or
correct.
10,000 or a million or 10 million.
Yeah, Kubernetes. Well, Kubernetes has an autoscaler functionality built into it. We understand that in our integration with Kubernetes, and we will scale up nodes, a new node to handle extra traffic, or scale down if need be. Millions of users is quite aggressive. We would put that in a special environment, but certainly auto-scaling is there. Yeah.
And your 45 tasks that you referenced earlier just completed, so that's 45 tasks you did not have to manually go through and toil. Okay.
Correct. I didn't build a Kubernetes cluster. I didn't fetch the containers. It took 14 minutes to complete here, completely dependent on how fast my storage is and my provisioning engine is. So if we wanted to delve in and see what the steps are, we could see them. This, again, is customizable. And you can see quite a lot of work is done behind the scenes to get all of that ready.
In this case, you're still using Postgres and all that?
Postgres is provisioned already for this. We can provision it via the same mechanism, the same automation mechanism. And we can log in now using kubectl, or we can log into the application here just via this URL. And if I click on here, there's the application that we just used, ready to go. Any number of instances of it across different members of a testing team. So what you saw then was automation of a single deep learning VM or automation of a multi-node Kubernetes cluster for scaling, auto-scaling, as the gentleman described. Okay. We're close to time. We talked about cost on GPUs. We definitely want to keep an eye on our GPUs. And so operations, which is a VCF tool that comes within the portfolio, paints this beautiful picture. We're going to take red out of it, by the way. But this is a picture of how hot, in terms of temperature, are my GPUs. How much is their memory usage and how much is their core usage? Red in our first iteration means underutilized. We're going to change that color because as your frown hints to me, and I know very well, operations people don't want to see red, ever. They want to see blue for underutilization. What we thought was we'd highlight the opportunity here of all of these GPUs are doing nothing currently. You have plenty of room for your capacity planning to put more workload on. And we have several dashboards here to allow us to drill down and see where that problem GPU is. And actually, if the GPU is at 98% memory, we want to know how long did that last, memory consumed. Large language models are notorious for consuming large amounts of GPU memory. And actually, the serving infrastructures are changing underneath them to optimize that memory such that they can fit into smaller spaces. But for now, we really want to know how busy our GPU is and how hot is that GPU in temperature terms. Final thing here, model gallery is brand new. It's new in the latest version of our product, our VMware Private AI Foundation product. And it's the idea of using a deep learning VM in the left-hand rectangle to test out models for accuracy, for bias, for suitability for my business use. That could be done in a deep learning VM, which resides in a safe zone called a DMZ. When the model is fully tested, and we do this actually internally, one of our data scientists tests every model they can lay their hands on from Hugging Face. When the model is proven, we push it up to a repository such that either it can be used for application development or even placed into production. And we have a user interface inside the company that shows you model 1 to n. Which one do you want to use to summarize your PDF document for you? I used it yesterday. It did a great job on a very technical document. So this is the first step into MLOps, into governance, into control, and you're going to see more tools.
A lot of the model MLOps kinds of configuration control includes data used to train it, and model versioning numbers and things of that nature. I mean, where does that apply to a Harbor container registry?
So the model that we've pulled here is purely the weights. Weights and some metadata surrounding it.
So you don't know what was used to train it. You don't know what was used to fine-tune it.
We can find that out, but it's not included in the model deliverable. Right? We know the name of
building a model card or anything like that.
No, we're expecting Hugging Face to have the model card to fully describe the data in it. It's a good idea that we would consider for a future development, and thank you for that idea. But currently, when you download the model, you effectively get a file containing safe tensors, weights that determine which tensors are important and which are not.
Yeah.
But if you wanted the heritage of the model from when it was trained, that's an interesting suggestion. I'll take that back to our R&D folks and see if that's applicable. But essentially, it's the weights today. It's pulled down from Hugging Face or wherever. It's tested here for all of the things the enterprise needs and then pushed into a repository at end of testing time. Okay, so I refer to our VMware validated solution document, our guidance. This is where you'll get some of the information you needed on the sort of lineage of these things. We can also discuss that offline with you if you like. There are several private AI guides and even a document that addresses security and RAG.
Yeah.
There's a lot of information that you can get from us on this. And thank you. Questions?
Yeah, I do have a question. So you talked a little about the stack where you control the different versions and you validate it and so on, which saves the customers a lot of time. How frequently do you update that stack to your customers? I mean, if you look at when we talk about generative AI, I mean, NIM every 6 months there's a new release. So how do you? What's your frequency? How frequent do you update?
You're absolutely right. The pace of change is very
Right.
high here. We're talking to NVIDIA on a weekly, if not daily basis
Right.
about where they're going with versions of the NIM, where they're going with versions of the retriever, etc. These things are changing regularly. We settle on a version and we keep it stable for 6-month intervals at least.
Okay. Right.
So there's nothing to stop somebody who has the appropriate access from saying, I need to upgrade that thing,
Right.
or I need to change the automation tool to see the latest version. You can do that as a custom piece of work, but we will stabilize on a particular set of versions. 2407, for example, of the NIM is the current one that we will build into our automation tool for you.
Right. So you basically every 6 months you potentially have a new release. How long do you support a version? Thank you.
I believe that's in the years. Yeah, I don't know exactly the span. That's the first time I've had that question, Frederick. I don't know exactly the span, but typically we support software for years.
Right.
And it's not a new private AI version. It's a new NIM version.
It's a new NIM version.
Yeah,
Yeah,
that you would
yeah.
support.
In fact, inside the company, all of us developer people are working on different versions of the NIM in
Or
concert.
retriever or whatever. Yeah.
Yes, in concert.